Hey guys, welcome back to Mr. Steve's Maths channel. Now we're going to have a quick look at some vertical stretching of a quadratic. It's the top little bit of notes here on your handout. Now the rule is y is equal to k outside the brackets of f of x does the vertical stretching, but there's two things. I want you to read this green box here and the two little points that it makes. So vertical stretching is the thing. We've got a rule. You should be getting used to how to do this now. But it says if k is greater than 1, the points move away from the x-axis. If you have a little look at that picture there, that should make it clear to you what that's trying to show. And if k is between 0 and 1, so like a half or a third or something like that, they move towards the x-axis. So I'm going to do one of each in this video, and then we'll have a look at the graph and see the impact that it's made. But it's k outside the brackets in like f of x. 1 bigger than 0, 1 between 0 and 1. So let's have a look at those now. Now I have a, what's my function here? Oh, that's a tricky one. Right. 1/2 of x squared plus x minus 7.5. Okay, well, this is what we're going to do. Actually, do you know what? No, I'll use it. I'm going to use it. It's fine. No, I won't. It's too confusing. Some of the people that are needing to watch this video are going to struggle with the fractions. So I'm going to get rid of all of this. I'm going to use a different one. I'll just make one up right now. This is something I use this one for something else. 3x minus 5. Let's use that. Okay, that should be a bit more obvious. Right, this is our quadratic we're using. X squared plus 3x minus 5. And let's get a whiteboard going here. Okay, so pretty sure I had graphically, we've got y is equal to f of x. I'm getting better at using my pen tool. F of x is equal to x squared. Did I say plus 3x plus 3x minus 5? Right. Now the rule said to multiply it by k outside the brackets. Let's do it in blue. So to vertically stretch, vertically stretch. Let's double it by scale factor of 2. That 2 and that of is a bit close for my liking. Let's just split those up. Oops. 2 by scale factor of 2. Y is equal to 2f of x. All right, so let's do the work. So if we go, so 2 times f of x, that's equal to 2 outside the, oops, what have I done there? I don't want that. I want it in blue. That 2, and then my original function, so x squared plus 3x minus 5. So x squared plus 3x minus 5. So all I've got to do here is multiply everything by 2. 2, whoops, what was it? X squared plus 6x minus 10. Right, I'm going to call this equation 1. Or maybe I should call it equation 2. We'll call this equation 1. All right, so to vertically stretch by a scale factor, that C is not great. Factor of 2, this is the little bit of working out here, not very difficult at all. Let's just do another one. Let's do it in pink. To vertically stretch, I'm not going to write all of this now. You can see what it says up above. Stretch, scale, oops, scale factor. To vertically stretch, scale factor of 1/3. Y is equal to 1/3 f of x. Okay. Actually, I don't need all these brackets. I can just do this. 1/3 f of x. That's okay. All right. So let's just do this now. This is going to be our equation 3. So 1/3 of f of x is equal to 1/3 of the original plus 3x minus 5. Okay. 1/3 times x squared is 1/3 of x squared. 1/3 times 3x is just an x. 3, like if you split 3 into 3 equal parts and just have one of them left. And if you don't know how to do these, I'll just quickly do it on the side for you. A quick refresher on fractions. So I've got 1/3 times -5. Well, this is the same as 1/3 multiplied by -5 over 1, because you can have a denominator of 1 for anything, and that's just the top times the top, bottom times the bottom. If you've never heard me say top times the top, bottom times the bottom for fractions, I don't know what you've been doing. I don't think you've ever listened. If you're hearing that for the first time, no, that's not fair. Not everyone's had me in middle school, but it is true for multiplying fractions. Top times the top, bottom times the bottom. Here we go. So we've got, and this is going to be our function 3. So I'm going to call this one g of x when I graph it, just so we can see that, like, this is just still function notation. I'm just showing you that it's different than, it's just the next letter after x. So it's like, this is the next function. I'll call this one h of x. This is the next function after that, but they're going to be our 3 graphs. So if we got this right, vertically, everything should be twice as far away from the x-axis as it is right now for this one. And everything should be like 3 times closer for this one here. So I'll go back to Desmos and we'll graph them to make sure we got it right. Let's go back to Desmos. Okay, let's do this. All right, so let's call this f of x for starters. So the one we wanted should be 2 times further away was g of x is equal to 2x squared plus 6x minus 10. Now let's pop this in. Well, actually, let's do this one in black. This can be our original. Black, done. Right, well, let's check some points here. So here we've got a turning point here. The turning point looks to be -1.5, -7.25. So let's just do that. I'll pop that in. -1.5 is -3/2. And what was it? -7.25. That must be 29/4. There we go. We'll make this one black as well. Right, but we've got a turning point here. We'll label that. And there it is, turning point. So we wanted this to be twice as far away. So I should be able to double all these values, which will make it -3. Oh, sorry. The x bit stays the same. Don't double all the values, just double the y value. That's a bit of a mistake, but anyway, I've fixed that already. So half of 29/2 is 29/4, 29/2, or double it, sorry, double, and make that blue. Okay, and we'll label that. So here we go. This point here is the turning point. Well, the next one's double far away, like 7.25. If you double that, you get 14.5. That's twice as far away. If you look at the x-intercept of this one's -5. This one's -10, so it's twice as far away. Sorry, the y-intercept. And what you'll also notice is the x-intercepts are the same. It didn't matter what the x-intercepts were, because at this point, we're trying to say, like, it's going to be twice as far away as it was for the original one, but it's on the x-axis. So twice as far away is still on the x-axis because it's 0 far away. Let's just look at the last one, h of x. I said I wanted this one in pink, didn't I? Maybe we'll turn the blue off for a minute. And we'll pop pink up here. So it should be 1/3 of x squared. You go back and check that part of the video, but it was plus x and minus 5/3. And let's make this one the closest to pink that they have. They've got, oh, Desmos letting me down. Desmos.com, if you're watching, hit me up with a like and subscribe, and maybe like some sponsorship or whatever. But also, please add pink to the color palette on functions. All right, so here we go. This should be 1/3 of the distance away. So let's have a look here. Well, I'm not gonna bore you with the fractions working out, but if you think about chopping this distance here from this black turning point towards the x-axis, at the moment that's 7.25. We chop that into 3 equal bits. We're going to end up with about not quite 2.5, a little bit less than that. So that's 1/3 of the distance it used to be, and that was the impact. Let's get rid of these. That was the impact of multiplying by 1/3, and that is how to vertically stretch your function.